Rotational symmetry. A figure has rotational symmetry if on rotating through some angle about a point it looks exactly the same. We call it a rotational symmetry. For example, in this figure, if we rotate it through the center, that is where I have put the cross. So 1, 2, 3, 4 are marked. This means rotation. So if I rotated this, second will be this. 1 comes in the position of 2, 3 and so on. So this is the rotational figure of this. So it looks exactly the same, but 1 is here, not on the top. So next is again we rotated. So this one comes down, 2, 3 and 4. The figure looks exactly the same but is not the original one. Next is again on rotating, figure looks exactly the same, but this is not same as original because in this original 1 point is on the top. Again we rotated, so this one is the original. So in how many steps we got this? 1, 2, 3 and 4. So we say order of this is 4 and this has a rotational symmetry. So we write this has a rotational symmetry and in how many rotations we are getting the original one? 1, 2, 3 and 4. So we say order for this is 4. And what is the angle of rotation? So for this, angle of rotation is equal to 360 divided by order of rotation. So order is 4, 360 divided by 4. So angle of rotation comes out to be 90 degree. So that means in first case when we rotated through the angle of 90 degree. Again 90 degree, 90 degrees and 90 degrees. So for this, order is 4 and angle of rotation is 90 degree. So a figure has rotational symmetry if on rotating through some angle, it looks exactly the same. Second is, we have an equilateral triangle. 1, 2 and 3 are marked, and if we rotate through the center, that is through the cross. So on rotating, 1 comes down, 2 here, 3 on the top. Again on rotating, 2 comes on the top, 3 and 1, and again on rotating we get the original shape, that is 1, 2, 3. So for this, order of rotational symmetry is equal to 3 because we are getting the original figure in this 1, 2 and 3 steps. So order is 3 and angle of rotation is equal to 360 divided by order of rotational symmetry So order of rotational symmetry here is 3. So 360 divided by 3, that is 120 degrees. So we are rotating this first figure through the angle of 120 degrees, again 120 degrees and again 120 degrees. So this is the angle of rotation and order of symmetry is 3. Third one is, I have this figure 1, 2, 3, 4, 5 and 6 are marked. There is a cross in the center, that means through that point we are rotating this figure. So when we are rotating this figure, we get 6 on the top, 1 comes this side, that means we rotated it like this. So 1, 2, 3, 4, 5 and 6 on the top. Again we rotated this figure from the center. So it comes 5 on the top, 6, 1, 2, 3 and 4. Again we rotated this figure. So 4 on the top, 5, 6, 1, 2 and 3. Again on rotation, 3 on the top. Again we rotated this figure, 2 on the top, and again on rotating we get the original figure, that is 1, 2, 3, 4, 5 and 6. So we are completing this in 6 steps. So order of rotational symmetry is equal to 6 and angle of rotation is equal to 360 divided by order of rotation. And order of rotation here is 6. So 360 divided by 6 comes out to be 60 degrees. So that means we are rotating this figure every time through the angle of 60 degree, and order of rotational symmetry here is 6.